Okay, all right then. Okay, welcome back. We are going into our next slide, Aon and PDM concept, and subsequently, the last slide, I will zoom in into what we call PDM calculation. Okay, Aon is basically quite a simple diagram. Instead of using arrow, now using node. So I need to introduce those things first. Once we understand the concept, then perhaps we can understand how it is going to be applied in a much complicated diagram called PDM diagram. Okay, we already mentioned about critical path method. Critical path method is the calculation method in order to generate critical activities and critical paths, and then we can calculate total float and free float so that we can understand better about the relationship between one activity and another. And we can use this critical path method in AOA diagram and even Aon or PDM diagram. Okay, so remember Gantt chart, AOA diagram, Aon diagram, PDM, or even line of balance is just graphic representation of the scheduling, whereas critical path basically is a calculation method. Okay, so then don't get confused with that. And I already mentioned AOA diagram was being developed way back in 1950s. And then in 1960, Aon diagram was even developed in Stanford University by Professor Fundel. And subsequently, this Aon diagram is the one being enhanced, okay? Enhanced, and now what we are using most of the time is basically PDM diagram. Okay, PDM diagram, because PDM diagram introduce many extra relationship, including the lag time. Whereas the original Aon using finish to start relationship only. Very similar to AOA diagram. Okay. All right. So in order to construct network diagram, for sure we must come up with the list of activity from our WBS, and then we need to compute the duration for each activity, and then we figure out about dependency, or we call it predecessor or successor, doesn't matter. The most important thing, you know which one basically relate to other. And then for sure, CPM calculate the longest path, and eventually we can know which are the critical activity and non-critical activity. The differences between critical and non-critical are not basically because they are not important. Maybe the word non-critical, critical, we thought that it is not important. No, all the activity are important. Otherwise, we are not going to put them into the listing. The non-critical and critical is only a matter of whether they do have free time or not. If activity doesn't have any free time, then those activity can be considered as critical. Whereas non-critical do have free time where we can adjust whether to start early or to start the latest date or to start in the middle. Okay, it is up to us. Okay, that is the concept. Prioritize activity. Okay, now let's see. For instance, sometime in the real situation, we might encounter delay, for instance. Okay, we might encounter delay. So how would basically you do? Sometimes the activity is very long. Okay, if for instance this activity and then connected with the following activity, what happens is that if you already completed certain portion and then you experience delay, okay, for sure this activity will be extended further, isn't it? And this activity will have to be pushed back. So sometimes that's why sometimes when you update a project, you can split the activity. You can split this activity, and then subsequently even the following activity can, certain portion of activity can be connected instantly. So you don't have to wait for the whole activity to complete, especially when you are doing large span of slab or many unit of houses, you don't have to wait. Okay, otherwise you are going to prolong the entire project. If resources are assigned to activity, reduce the duration of those resources, increase the number. Okay, if you are running late, for instance. So again, once we understand how the duration of activity was being calculated, then perhaps we will appreciate duration has something to do with the resources that we use. If we are running late, so you have to increase resources. You have to bring the bigger capacity of machinery or number of laborer, etc., etc. Then change appropriate your calendar. We are the one that come up with the we put holiday. Certain day of the week is basically holiday. If we are running late, then basically we should scrap some of the holiday. We should even work in shift. We should prolong the day shift instead of going back at 6, going back at 7 or even 8 every day. Then perhaps we can catch up. Okay. To start, activity. If you are using finish to start activity, meaning to say that the following activity had to wait until all the activity completed. Why don't you use the concept of what we call overlap? This overlap, remember the word lag that I mentioned to you. Lag, basically, there is a lag positive and also negative. But normally we say it is a lead. We need to say we overlap activity. Don't wait for the activity to fully completed, then only you want to start the following activity. You can start the next activity a bit earlier. So in that situation, you can get a head start. Okay, that is the concept. Divide long activity into several shorter duration activities so that the following activity can even start immediately without waiting for the long what we call bar chart there to be completed. Okay. Benefit, basically, once we use the network diagram, regardless of any diagram, AOA or PDM, Aon, for sure, the concept of diagram is basically interconnected activity. We can see the impact directly on the following activity and subsequently on the project duration. Okay. Software is very good in terms of it can basically react very fast. One, there is a changes that you input, then automatically you will know. Okay, and then the issue of updating. Okay, now PDM. Okay, PDM dependency. I already mentioned in yesterday's slide, but now we want to zoom in again, maybe perhaps giving you example. Finish to start relationship. Finish to start relationship meaning to say, let's say plastering completed. Then after that, we start painting. Okay, we can start painting. Why? That is basically the sequence. You cannot do painting without plastering. Okay, so after completed, then painting. But if, for instance, you have a big wall, the entire long span of the building there, why you had to wait for the entire plastering to be completed, isn't it? You can basically start painting much earlier. This is what we call overlap. So you do the painting on the side which has already dried out, the very far end, or the one when you start plastering, not on the same spot. Anyway, you cannot do that. This is the concept. Okay. So if this is the situation, the relationship will be finish to start, negative for a few days, minus let's say 3 days, for instance. So meaning to say you overlap by 3 days. So instead of concept the painting basically start immediately after you finish plastering, but it can get a head start. That is the concept. But later on we do have another example. Now we just want to show you in terms of relationship first. Okay, start to start. Start to start meaning to say both activities start at the same time. But if I draw something like this, this might not be accurate. Normally, I should have one tail and one arrowhead. So in this situation, if I have another activity, let's say maybe after I completed the cut and fill, topsoil removal, then I can start cut and fill. Okay, I can do this. But if, for instance, these two activity are the starting activity, I should basically delete the arrowhead. So the tail will be coming from cutting and then go into filling. But the most important thing, basically, they do start at the same time. So that's what the relationship basically indicate. And then finish to finish. Finish to finish, again, if, for instance, these are just simply two activity, okay, I might delete this. I just delete this arrowhead so that one arrow going into another box, okay, where basically it exit and then where it basically enter. But if, for instance, you draw something like this and then it is going to be connected to something else, that will be another story. Okay, normally, so one tail, one arrowhead. Okay, so it looks the same in terms of cutting and filling, but the most important thing will be the finish, the timing of the finish or the timing of the start. And lastly, this is the one that I mentioned to you before. It looks very funny. Start to finish relationship is completely the reverse from finish to start relationship. Okay, in what situation? Okay, it looks like this could be the situation going backward. Let's say you want to lay brick. You want to start laying brick, start. But then when you want to start laying brick, start. So what are the activities that should be completed first prior to laying brick? This is what we call finish. Brick delivery. If you want to lay brick, for sure the brick had to be delivered. Okay, instead of saying finish to start, now the other way around. So that's why I say it depends. This kind of relationship might be a little bit rare, but you can use if you want. So similarly, how about the start of brick delivery? So the start of brick delivery can commence once the procurement basically finish. You see, the relationship is basically start to finish. And then how about the start of procurement? The start of the procurement, you can start the procurement once you already your sample already approved by the consultant. Okay, otherwise you cannot purchase your material. And then how about the sample? In order to get the sample approved, okay, you must submit the sample first. Otherwise, for sure you cannot start the approval. The submission must be done. Normally, in this kind of situation, we are going to use this thing for procurement schedule. Procurement is basically the purchasing of material procedure, or even for the ISO. We work backward. Perhaps another example, okay, that I can give you. Let's say this the crossing river. Let's say this is the old bridge. Okay, the old bridge. Still, the car is still using every day, and you are constructing new bridge. Okay. So the issue is that when can you say, okay, let's say that the activity is demolish old bridge. When can you start demolishing the old bridge? Start. You can only start demolishing the old bridge, see, once you already complete, or you basically hand over, let's say, hand over the new bridge as one of the last process. There could be many process before that. We don't care. You see, this is what we call start to finish relationship. So in this kind of relationship, it just want to emphasize the very important connection there. You simply cannot start demolition of old bridge unless you hand over the new bridge. Okay, when the new bridge is being hand over, meaning to say people can use this bridge anymore, and then the demolition of the old bridge can basically begin. That is example. Okay. All right, now we come into lag and then subsequently lead. Okay, this is example. If, for instance, finish to start relationship, if it is just finish to start relationship, so normally in terms of drawing, let's say activity A and then activity B. So this is the connection. Immediately after you complete activity A and then activity B will start. But remember, in reality, that activity B will not be starting on the same day. Let's say activity A, we will start the project 2 days, Monday and Tuesday. Okay, so Tuesday, activity A is going to be completed. So B will start immediately. It doesn't mean that B will start on Tuesday. No, because when we complete A on Tuesday, that is the end of the working day already, maybe at 6. So we cannot continue B on Tuesday. We are going to start B on the following day. But in terms of calculation, let's say for A is 2 days and B is 2 days. In terms of calculation, 0 plus 2 equivalent to 2. Then 2 plus 2 equivalent to 4. But in reality, if we put into the time frame of the day, this is day 1, day 2. This will be the activity A. And then the following day, on the 3rd day, okay, on Wednesday only can those activity B can start. Okay, don't get confused with whatever that we schedule is based on working time or working days. Okay, now lag time. Imagine post slab. Okay, wet concrete. Okay, if you just simply pour slab on a small piece of floor there, like say 1-story floor, one house, for instance, normally you are going to wait for a few days, okay, 1, 2, or 3 days, whatever, for curing process. This is what we call curing. Let's say curing, in order to erect your column. That is the logic of what we call scheduling. But the curing process, you do not want to include as one activity. You don't have to do that. Otherwise, every time you concrete, then you put curing as one activity, then the whole planning will be full of curing process everywhere. And no need. But then we use lag. So we are going to indicate in our drawing either +2, something like that. So you understand. You already understand that this is finish to start relationship. +2 meaning to say the column will start, sorry, +3. According to this one is +3. +3. Okay, now let's give some value. Let's say post slab is 3 days. Okay, let's see here. Let's say 3 days. Column also 3 days. So from the calculation, 0 plus 3 equivalent to 3. Then 3 have to be added with 3. Then this column will start on 6, not 3, on 6. 6 plus 3 equivalent to 9. See? By right, if you add 3 plus 3 is equivalent to 6, they can be completed in 6 days. But because of the lag here, we delay the starting of the following activity by 3 days, then we should basically account it into our calculation. So at the end of the day, column will be a little bit late in terms of finishing. That is the concept of lag. Okay, now, how about lead? Okay, if we mention finish to start, the way we write is something like this: fs minus 2. That is the concept. This one is fs plus 3. Okay, fs minus 2. You focus on this value, the start. This letter here, the start of the following activity. So remember, this is F, this is S. It is the following activity that being lead. So the word lag in a certain book, L-A-G, always being referred to either lag positive or negative. But in some books, instead of saying lag negative, we call it lead. So perhaps using the word lead, then you can understand. The starting of the following activity is going to be lead. Lead means to say we start much earlier. We start a little bit earlier. Supposingly, if without the lead, you are going to start your activity here, this. But now we lead, we start a little bit earlier. Earlier from what? From what? Remember, the way we draw the diagram is from left to right. Remember, these indicate the first day of work. First day, second day, third day, fourth day. That's why when you go back in terms of the starting point, meaning to say this is what we call earlier, this is what we call later. Because of this, the time scale that we use and the way we draw is from the left to the right. Okay. All right, now start to start. Start to start with 5-day lag. So if, for instance, without this thing, how are we going to draw? Okay. If, for instance, start to start. Okay. Start to start without the lag. But now, because we do have 5, okay, we do have 5 days lag, what happens is that the starting of this thing is being delayed or pushed at a later date by 5 days. This is what we call 5 days. Okay, 5 days. So from the calculation, okay, now let's take a look at the calculation. Let's say both are 3 days and 3 days. And we start 0. 0 plus 3 equivalent to 3. But then because of the start to start here, what happens is that this is 5 day plus, you need to add this one, 0 plus 5 equivalent to 5. 5 plus 3 equivalent to 8. Now your project basically end in 8 days. Why? Because you delay the starting of the following activity by 5 days. That is the concept. And then FF with -5. FF is -5. Okay. Finish to finish. Okay, by right, if let's say without this thing, you are going to draw the diagram almost like this. Finish to finish almost at the same time. But because of the delay, okay, you basically delay the finish at a later stage. So basically, remember the later stage is basically on the right side is always the later, and on the left side is basically the earlier. So you push the finishing a little bit later. Or if, for instance, instead of +5, let's say you put -5 or whatever the value. So you have to push it to the left side. but sometimes it has to be, the logic must be there, okay? It is almost impossible, for instance, you basically complete the plastering much more in advance than laying brick. Partially you can, okay? So the logic must be there, eh? Okay, later on we are going to see how those kind of lag and lead will go into the calculation. So as for the early start, early finish, late start, and late finish, they are all the same for either AOA diagram and even AON diagram and PDM diagram. So I do not want to go into the definition again. Okay, forward pass. Forward pass is the same concept. Again, this is just a revision. If you do forward pass, you are going to get the early start value, early finish value for sure. And then, you know what? From this statement, you can even calculate free float. Because remember, the free float definition is the difference between early start of the previous, the successor activity and early finish of the current activity. So those value you already get. You can easily get the value of free float without even completing the whole calculation. And of course, you will get the overall duration. When you complete your backward pass, you will get late start and late finish. And for sure, you are going to get, going to know the total float of each activity. And once you know, for instance, you will end up with the identifying the critical path. That is the concept in the critical path calculation. If we do step by step, at the end of the day, we are going to get the information. And this is an example of a network diagram based on AON diagram. Every activity now is being put inside the box. So you must, maybe this morning, we are telling you about AOA diagram, but now it's completely, you need a paradigm shift here because the drawing look different, okay, where the activity now is inside the box, whereas the arrow just indicate the relationship, either finish to start, start to start, finish to finish, start to finish, and etc. And for AON diagram or CPM diagram, let's say the diagram simply give you A and D as a starting. You can add, start and finish what we call activity. This is what we call milestone diagram. In order to make the diagram close, you don't need to have this thing. In arrow diagram, yes, normally we are going to have a very close kind of network. But in CPM or AON diagram, PDM diagram, you are allowed to have those kind of things. But I would advise any network development to have the start and finish. Then only you can see sometimes your critical paths are nicely connected. Okay, nicely connected together. Otherwise, you can see that there are certain activity are hanging around, which is we do not know where does the activity connected. Okay, by right, this should be the right drawing. Okay, now let's take a look at one example. Simple example. Given the task name start until finish with A, B, C, until H, duration is there, and then predecessor is given there. So the start doesn't have the predecessor. So that is the starting point. Task number. Task number is in Microsoft project. This ID will be generated automatically. And remember, in Microsoft project, the computer do not recognize this type of predecessor description. We need to use this ID. For instance, activity A, the predecessor is start. We simply cannot use the word start. We need to use the ID. So what is the ID for start? It's basically 1. That is the way. For B, the predecessor is A, so A is basically 2. So C, the predecessor is B, B is basically 3. We use the ID. Microsoft Project use the ID, but for our class, for easy references, we just simply, we normally do not show the task ID, we just simply going to use predecessor based on the task name. And you notice that in this predecessor, it doesn't indicate any finish to start, start to start. If it doesn't indicate, meaning to say automatically, all of these predecessor, we assume finish to start, unless noted otherwise. Okay, unless noted otherwise, then only you have to follow start to start, finish to finish, or whatever. Okay, now let's take a look at this example. Okay, let's go into drawing first. Okay, first activity, start. So we draw the box here, the start. Okay, then there are two activity. Then A. We take a look at what are the activity that connect from start. Oh, it looks like two activity, A and E. A and E. So what we normally do, we can just simply draw one box and then two box, 1 and 2, and we name it A. Then we name it E, and then the arrow will be connecting from start into our two box there. That basically represent this one. A connected from predecessor start, E connected from predecessor start. Then we go into B. B is connected from A. Okay, now we already draw A, so you need to draw box B, and then you simply connect from A, because it is finished to start. Remember, the box, as I told you, on the left side indicate start, on the right side of the box indicate finish. So it basically repeat after itself, and then start, finish, that is the concept. Okay, that is the concept that tell us about finish to start relationship. Okay, next would be what activity? C. C is connected from B. Okay, you draw C and then you connect from B, and then what else? D, C and H. Okay, D, C and H. Okay, you draw whatever box. You might put the box up there, here, doesn't matter. So the drawing might not look similar to what we have here, but as long as the connection is right, that should be right. Okay, let's say that would be your D. It's okay. But then D is also connected from H. H is not in the drawing yet. You can just simply put H anywhere, then you connect into a D there. So you get D already, and then also H. Then you go down again the listing. D is okay. Then E is there already. Then F. Okay. F is from E. Okay. So E is already there. So you just draw F. Okay. You just draw F here. And then what else? Hey, G. Okay. G is from E. Okay. G is from E. All right. Then the last one. The last one is basically H is from G, F and G. So H is already here, the one that you get from D previously. So you just need to connect and then connect. And that's how you draw the network diagram. Okay, this is AON diagram. Why? AON diagram normally do have what we call finish to start relationship. Now we want to go for forward pass calculation. Okay, forward pass calculation, we are going to fill in the top portion of the value, early start, early finish here. How do we get that? We just simply add, similar to arrow diagram, but everything is happening inside the box. So that's why Aon and Pdm diagram is now widely used, because of all the values being shown in the box. You are not going to get confused like the arrow diagram. Okay, now let's go into calculation. Actually, we start with 0. Duration start basically doesn't have 0. 0 plus 0 plus 0. That is the concept. Then this one being transferred here, and this one is being transferred here. So the starting for A and B is also 0. So we start with 0. 0 plus duration. Duration is here. Within the box, 0 plus 7 equivalent to 7. And then, because it finished to start for to B, so this value will be transferred here. 7 plus 6 within the box, equivalent to 13. Then in between box, you need to look at the relationship. 13 will be transferred here. 13 plus 3 equivalent to 16. Okay, now we go to the E first. 0 plus 3 equivalent to 3. 3 transfer here. And also 3 will be transferred inside this box. Okay, 3 plus 3 equivalent to 6. 3 plus 2 equivalent to 5. Now for H, there are 2 activities going into this box. Remember, the forward pass, we are going to take the bigger value. Between 6 and 5, we are going to take here this value going into this box. 6 plus 2 equivalent to 8. And this one will go into this box. So which one will be chosen? For sure, the bigger value, 16. 16 plus 4 equivalent to 20. So this is the overall project duration. So we already get the answer. Okay, one answer. Okay. Now, if we want to complete the diagram, okay, let's complete the diagram by calculating the forward pass. Okay, forward pass. How do we do forward pass? So forward pass is total float. Okay, second here, forward pass, backward pass first. Okay, have any? Okay, backward pass. Here, 20, you copy back into here, and then you will deduct with duration within the box. Okay, 20 minus 4, you get 16. Then you transfer according to the line here, going into this 16. Transfer first, 16. Then you calculate, you deduct within the box. Okay, 16 minus 3 equivalent to 13. And then for H, 16 minus 14 equivalent to 32 equivalent to 14. For B, for instance, you transfer back into here, and then calculate within the box. 13 minus 6 equivalent to 7. 7 transfer here. 7 minus 7 equivalent to 0. Okay. Then we go into F and G. Remember this value, you will transfer according to the arrow, going back arrow, 14 here. Then you subtract within the box. 14 minus 3 equivalent to 11. Then 14 minus 2 equivalent to 12. Okay, then when you go back to this value here, now you have to decide which one is the least value, the smallest value for backward pass, similar to arrow diagram. Okay, so the 11 will be chosen to be here. 11 minus 3 equivalent to 8. Okay, remember we start with 0. 0 plus 0 equivalent to 0. And at the end of the day, you see this 0 is here. This is 0 that go back to the starting point. 0 minus 0 is basically we go back to 0. So now we already completed our network diagram, all the figure, except that we need to calculate, let's say, total float. Okay, now come the total float. How do we calculate total float from this diagram? As I mentioned to you earlier, if we use Aon diagram or PDM diagram, all the value, early start, early finish, late start, late finish for each of the activity are being shown here inside the box here. See, everything is there. So we do not mix around, unlike the arrow diagram where some of the value, because inside the node there only we select which one is the bigger value or least value. That is the issue. Okay, so for total float, you can use this formula. This is what Zam has been asking before. Let's say for H, you can take this 16 minus 8 or 14 minus 6, either one, which is equivalent to 8. Okay, 14 minus this one minus this one is equivalent to 8. 11 minus 3 equivalent to 8. For G, 14 minus 5 equivalent to 9. And the rest, you see, if these figures are the same, this one must be 0. 0, 0, 0, 0. Total float 0. And when total float 0, those activity A, B, C, D are being considered as critical activity. And when they are connected together, they are being called critical path. Okay, remember, inside the network diagram, they could be one critical path or multiple critical path. Critical path is not singular. It could be multiple. But in our example, because the network diagram is so small, normally we do have only one critical path. But later on, we are going to learn development of new critical paths due to project compression. That will be the next 2 weeks. Okay, now example. Okay, you can take a look at this example. Normally, list of activity given, predecessor is given, duration is given. You can start drawing the network diagram. Okay, for instance, A. So this one you can add A, and then what else? B. B is coming from A, so you draw this diagram and then connect it from to arrow. And then C is coming from A, etc. Then basically you can start doing the calculation. Let's say the duration is 0. 0 plus 0 equivalent to 0. 0 transfer here. 0 plus 4 equivalent to 4. 4 transfer here. 4 plus 3 equivalent to 7. C, 4 plus 2 equivalent to 6. And then 6 transfer here. 6 plus 5 equivalent to 11. And then 7 and 11, which one is bigger? For sure 11. 11 plus 2 equivalent to 13. 13 transfer here. So basically, the end of the project is basically 13 days. That will be the forward pass. And then the backward pass is basically you copy back 13 into this one. This one is basically the same for finish. That's okay. 13 minus 2 equivalent to 11. 11 transfer back here. 11 transfer back here. And within the box, 11 minus 5 equivalent to 6. Then 11 minus 3 here equivalent to 8. 6 transfer here. 6 minus 2 equivalent to 4. And then you see, between 4 and 8, which one will go into here? For sure, we take the lowest value, 4. 4 minus 4 equivalent to 0. See, we start with 0 and then we come back with 0. So once you do that, then basically you are going to get the the total float and the critical path. You already know. When this one is the same, so the total float is 0, 0, 0, and then 0. Only this activity do have total float equivalent to 4 days. This activity can be delayed, whereas the other cannot be delayed anymore. All right. So you can take a look at another example. Okay. Also another example, you can do that at home. Okay, now let's go into our last slide for AON diagram very quickly. Okay, let's say this is the diagram, and the most important thing, the legend, early start, early finish, late start, late start, late finish, and total float. So I will start with this one, 0. 0 plus 2 equivalent to 2. 2 transfer here will be 2. 2 plus 6 equivalent to 8. Then 2 also will be transferred here. 2 plus 3 equivalent to 5. 8 will be transferred here. 8 plus 6 equivalent to 14. This one is also 8. 8 plus 1 equivalent to 9. And then you notice 5 and 9. So which one is going to go into this one? It will be 9. 9 plus 3 equivalent to 12. Between 12 and 14, of course, we are going to choose 14. 14 plus 2 equivalent to 16. So we are going to complete the project in 16 days. And then copy back 16. 16 minus 2 equivalent to 14. 14 transfer here, 14. And 14 also transfer here. Within the box, 14 minus 3 equivalent to 11. 14 minus 6. 14 minus 6 equivalent to 8. For D and then C, okay, this 11 will be here and then also will be here. And then within the box, 11 minus 1 equivalent to 10. And then for this one, either 10 or 8. For sure, we are going to choose 8. 8 minus 6 equivalent to 2. Whereas C, 11 minus 3 equivalent to 8. 8, okay. And for sure, what goes into this one is basically the lowest value, not the 8. 2 minus 2 equivalent to 0. See, you start with 0, we are going to end up with 0. So this one. And how to calculate total float very quickly. Again, here the differences between this one is this one you get 0, 0, 0, 0. So the one with 0 total float, and when we connect together, that would be the what we call critical path. Okay, now how about free float? Okay, free float. Remember, free float. The concept of free float is basically, remember, normally free float will appear in the interconnection, isn't it? Okay, that I told you before. This situation. The rest is okay. Okay, now let's take a look at D, activity D. Activity D. So free float for activity D is equivalent to, as usual, the formula is early start of the following activity. The following activity D and F. F minus early finish of D. So from this diagram, D, can you identify the early start of F? For sure, this is the early start of F, 9. How about early finish of D? Yeah, this value is early finish of D is easily available. It is written there very clearly. So if you compare between this value, 9 minus 9 equivalent to 0. So this FF, it is not finish to finish, except that we might not have space. We can put inside the box, maybe here, FF equal to 0, as not to get confused with the finish to finish relationship. But the one that I show you is basically the free float. And how about free float for C, this value? We can just quickly compare 9 here and 5 here. 9 minus 5 equivalent to 4. This is the value. Okay. Okay, now we take a look at A. This A situation. A, there are two activities. A and then B, A and then C. But in this situation, somehow, 2 minus 2 equivalent to 0. And from A to C, also 2 minus 2 equivalent to 0. That's why total float is 0 and 0. There could be situation, in any the situation, maybe you will get different value. Okay, different value. Let's say this one start at I don't know, maybe because the connecting activity could be coming from other activity. That could be the scenario. Maybe let's say 3. Then 3 minus 2 equivalent to 1. But for free float, there must be only one value for one particular activity. So in that situation, we are going to take the free float for A as 0, not 1. It is impossible because if you take one, it is as if you can also delay activity B by 1 day. In reality, you cannot, because the starting of B is already in day number 2, which basically must start immediately after A completed. You see, that is the scenario. Okay, so any question for AOA diagram? Any question for AOA diagram?